And there we go. Hi, Tristan. Good morning for me and good evening to you.
Hi, Reid. How are you?
Doing very well. How are you doing today?
Very good. I'm happy to be back on your channel and looking forward to this session.
Yeah, it's been it's his third or fourth time.
Yeah, third, I would
Third.
say one on AGS, the calculated columns, and now window functions. Yeah.
Yeah, each was DAX related in some capacity. Yeah.
Yeah. DAX. We love DAX, right?
Oh, of course, absolutely. Especially DAX calculated columns.
Yeah.
But yeah, good to have you back, and first time on the new channel as well.
Yes. I see that you have lots of followers on this channel too, like more than 40K. Good. Congrats. Good job.
Yeah. It's been a little faster to build this one up, I think, because we already had some momentum from Havens Consulting moving over to this. I actually just passed 100,000 subscribers on the other channel as of
Congrats.
6 days ago. So I'm hoping at some point soon where I can get the silver play button, because they give those out to the channels, and I want to put that like right in the middle, about right here on the back wall in between my lights.
That would be nice. Great milestone.
Exactly. At some point, I'll probably have two channels with that. So one for me, one for Steve in our offices. But yeah, like I think this is a good time of year with some interesting releases. DAX has certainly had an exciting year, I think, with the UDFs and time intelligence both having come out. It's been interesting to talk to Marco and Jay about that, I think, because they both expected the calendar and the time intelligence to be a lot more popular, but everybody's been talking a lot more about UDFs, and I think I'd agree with them on like the time intelligence one is going to completely change how all models will be built going forward. UDFs will change how some models get built going forward, because not every model will have a UDF, but every model should use the new calendar configurations, like just hands down. So it is funny that one's more evergreen in terms of, I would say, like cornerstone changes, but the other one's just so cool to use. I think that's why it's been so popular, is because people have had fun with a lot of like new patterns and stuff, and like reusable templates, which is why I think the UDFs have been so popular. But I am curious on your thoughts, maybe between the two of them, before we get like started on the topic of the day today.
I'm part of the people who are more excited about DAX UDF. I'm not necessarily saying that we are right, but that was the case for me. I haven't tried really yet the new calendar method and the impact on DAX and stuff. I saw that you published some articles and videos on this, especially insisting on one thing, which I was a bit surprised, where you were saying that sometimes it performs faster than the classic standard calendar.
It will almost always perform faster than the calendar. Like that, it's coming straight from Jay's mouth. Like the huge thing about it is the optimizations in the back end. If you ever construct a query in a visual that uses anything but the date column, it will always fall back to the date column when using date add parallel period to apply filters. So you could have up to like 2,000 or 3,000 filters in the query plan and be loading hundreds of thousands of rows more, because it has to make in the storage engine a query. But if you associate the pairings, it will then use those as the filter and not the actual date column anymore. So when I ran some tests on that, it went from like 380,000 rows down to 20,000 rows for the exact same visual. The only thing that I swapped was one measure was prior year, the original one, and then prior year using my Gregorian calendar that I set up, and it was huge difference between the two. So I think it's the performance implications, the big one, especially with really large models. I think that's going to be very fun, paramount in faster performance for native date functions. So that's why I think that's a big game changer. But it's not talked about as much because it's more technical, I think, to a degree, than UDFs. The UDFs make cool SVGs and all the other stuff, so it is more exciting. The calendar is more boring, but I think as people start to get more familiar with it, and realize the importance of it, I think it will, again, like in 3 years, I think that will every model should be using that new pattern going forward. Like that will be in the documentation as, like, previously it was set as date table, now it will be set as date table, associate your your calendar columns.
Yeah. You actually you convinced me to have a look at this and to make a deep dive. I will compare. Also, I would be curious to compare the of course the performance and also the capacity units consumption, which are more or less correlated, of course, but that would be interesting as well as a way to compare both methods.
Yeah, any like magic wand you can wave where you can just help the engine think better at running queries is like I'm all for that. Like auto optimizations basically with just a little bit of user configuration with no code. It's just a UI, to build that out. Is like I'm all in support of that stuff.
Yeah. I'm working on very large models, and where there are, of course, as always, lots of time intelligence calculations, and I will definitely have a look. But it's still in preview, right? So we have to be careful, of course. But yeah.
Sure. Yeah. The only things that I've seen so far with testing it is maybe the UI sometimes like throws a false positive where like you can't pair this with that because it's a mini to mini when it should be a one to mini or something. So like it's throwing a validation error. But that's the only personally the only issue that I've seen. Somebody online reported that it made theirs slower, but like looking at the query plans, I would be very curious of how, if you're literally loading like 200,000 less rows into the storage engine, like there shouldn't be any reason that DAX should be taking longer to do less. But I'd say test for yourself. But yeah, it just take a look at DAX Studio and watch how what the query becomes with those two. And it's crazy to see the how many rows get scanned and the differences on what it evaluates with all the T-SQL scripts.
Okay, nice. I will definitely investigate. Thanks for the tip.
Absolutely. But speaking of things that have been out in the last few years, we also have like the window functions and all that came out a couple, 2 years ago now, around?
Almost 3 years ago now.
Almost 3 years, yeah.
Yeah.
Doesn't feel like that long ago.
Yeah. Time goes fast.
So I know we'll eventually get to that, but I think let's, as we've done before, do a brief opportunity to give you a little bit of an introduction, introduce yourself to people tuning in or who will be watching later if you want to start from there, and then we'll segue into talking about the window functions.
Yes. So hi everyone, my name is Tristan. I am from France, as you can probably hear from my accent. I am 32. I've been in the Power BI world since 8 years now. I created a company called DataPulse in France. We do offer Power BI and Fabric consulting services and trainings. And I also created the Power BI user group in France, the Club Power BI, and more recently the Club Fabric, where we organize monthly meetups and stuff. I am a former Microsoft MVP, no longer MVP anymore, unfortunately, but I'm still sharing my passion and my knowledge to the community. So thanks again for having me today, and I'm looking forward to sharing the DAX window functions session today with you.
Yeah, absolutely. And fingers crossed you can get back in. I mean, even my business partner, Steve Campbell, was out for a couple of years. He got back in. There's been multiple MVPs that have, left and returned. So best of luck for you also re-entering if that's something you want to do.
Yeah, thank you.
Absolutely. But yeah, with that, if you're ready to get started, we can flip over to the screen share and take a look.
Let's go. Yes.
Here you go.
Okay. So the topic of today is about DAX window functions. This feature was released in January 2023 in Power BI. And basically, it allows you to create KPIs. It can be measures, it can be columns, it can be also tables or visual calculations, we will see later, that should allow you to navigate across tables and columns more easily. Reed, I think you forgot to shut down your microphone. Maybe I'm hearing some noise. I don't know. Yeah, I don't know. Yeah.
Let me let's test if I do this.
Yeah, should be better. DAX window functions allow you to navigate more easily across tables and columns, whether they are virtual or physical. I'm not gonna go into the details of each function, like the syntax and stuff. What I want to do instead is to show you the power of these functions through very concrete and practical examples. So today we will cover mostly index, window, offset, which are the most important functions, window functions in DAX. And they have companion functions as well that we will use later in the session, which are order by and partition by. So with that, let's start. To illustrate my session, I have a very simple star schema with the sales fact table, 2 million rows, and then a few dimension tables such as the product, stores, customers, and calendar. It's actually using the Contoso dataset. And I have regular standard one-to-many relationships between my dimensions and my fact table. So in this model, I already have some measures where I count, for example, the number of orders. Let me zoom in this a bit, or the turnover. So the first example I want to show you today, it's to work on rank and classification, let's say, of stores first. So as you can see here on the screen, I have the total sales per store. And of course, because this is Power BI, it's dynamic. It recomputes on the fly based on user selection and so on. Sometimes what you want to do is that you want to compute the top stores in terms of sales or average basket or number of order. So to do that, usually what you do, for example, total sales, let's say top 3 stores. Usually to do that, you do a calculate total sales and then you use, sorry?
Oh, sorry, I was just agreeing with you. Yes.
Yeah. This on the store key. Okay. Order by total sales descending. Okay, so this is quite a standard DAX pattern that you use in order to retrieve, in this case, the top 3 sales of your the sales of your top 3 stores. And of course, again, it recomputes on the fly by filtering on countries, brand, and so on. Okay, that's quite easy. But now, sometimes you have more advanced business needs, which require you to compute not necessarily the top sales, but you want to know who is, for example, the 3rd best store or the 4th best store or the 1st one. So you don't want to compute the value, but actually you want to know who is in which rank. Okay. And by the way, I have created here a very small disconnected table where I can pick and choose the number of rank that I want to display here. So 5, 4, 3, and so on. To make my DAX even more dynamic, I can switch here and say, okay, I don't want my top 3. I want to make it dynamic based on user selection. Okay. But now we're going to make it a bit more advanced. We're going to compute, for example, if I select 2, I want to know who is the 2nd best store on the fly, which in this case is this store. Yeah. So in order to do that, before window functions, there was a pattern which was released by SQL BI, which would allow you to do that. I'm going to show it to you here. This is a DAX code from SQL BI. You know, the Italian, they provide a lot of content on DAX and stuff. Of course, most of the Power BI community knows them. So as you can see, before the existence of window functions, in order to do that, it wasn't that easy because first you needed to do a first iteration in order to recompute on the fly for each store what is the rank of the particular store that is iterated, and then you needed to filter this table, this virtual dynamic table, in order to retrieve only the one who has the rank number 1. Here it's in descending order, right? And then once you did the first iteration and the second iteration, then you can get what is the corresponding store. So not that easy, as you can see, because it's quite long in terms of code. It's a bit verbose. it requires you to understand many things like virtual tables, context transition, variables, lots of things. And it wasn't that fast to compute, but at least it could make the job. So for example, if I use it here and I drag this measure on my screen, as you can see here, it displays number 1. And of course, I can make it dynamic here. Let me update my variable top choice equals top value, so I can get the value from the users. And then I can pass it here, okay, on the rank. So here, as you can see, it works. I select number 2, and then I get the number 2 of store, descending order, which is the store 500. And of course, because this is a measure, it recomputes on the fly. And now the second store is 450 and so on. Okay, fine. I don't know, Reid, what you think about this, but it's not that easy, right? In terms of algorithm and DAX understanding, it requires to be quite advanced to compute this kind of KPI, right?
I mean, you could reproduce it, but it's like if you actually ask somebody, "Oh, explain to me what this is doing," they'd probably be like, I just copied it from SQL BI. Yeah, it's hard to explain how the logic is producing the result of this, unless you're probably an intermediate to advanced user.
Yeah. Actually, we could ask Copilot or ChatGPT or whatever to say, okay, this is the code. Can you explain what it is doing? But still, it's a little bit advanced and not that fast because again, it requires to do multiple iterations to do that. Okay, now, since almost 3 years now, we do have functions in DAX which allow you to do this kind of thing much more simply. So let me introduce you to the index DAX function. So I'm going to create a new measure, and I'm going to call it top store equals. So I'm going to use this new DAX function, well, new 3 years ago now, or almost, which allows me basically to pick a specific position from a virtual or physical table that I'm going to be able to sort or even maybe partition. So let's do it, and then I will explain my code. So what I want here is the first, okay? Then the second argument is the table on which I want to iterate. So I'm going to say all selected store key from the store dimension. The third argument is actually how do I want to sort this virtual table. So order by total sales, descending, right? And basically, all the other arguments, such as the management of blanks, partition, and so on, are more advanced arguments that I don't really need right now, and they are optional. So let me just close this. As you can see now, the code, if I unzoom a bit, it can fit in only one row. So it's much simpler in terms of syntax. It's lighter in terms of code than the first method that you saw. And it works. So I'm going to copy and paste, and now I'm going to use my measure. So as you can see here, I have forced number 1 in my selection. And yes, number 1 is this store. Of course, I can make this dynamic and say top value so that it recomputes based on the user choice. So good news, it works. It returns the same good and correct result as the pattern from SQL BI. But as you can see, instead of this, we now have this, which is way simpler, at least in terms of syntax and let's say number of characters in the code. So now I'm going to explain to you a bit the internals of this, of how it works, and we will see some details. Before that, Reid, did you ever use this kind of pattern with the index in order to retrieve not the amount of the top 2 or top 3, but actually who is part of this top? Have you used that before?
And not specifically the index. I've used some of the other window functions, but never the index to retrieve a range. But I do like the pattern itself compared to what you used to need to do to be able to get those.
Yeah. So that's why, okay, so I'm going to explain this and maybe you will be interested too. So actually, let me show the code. So what this does is actually, it starts from this virtual table where I get, let's say, a list of store, S1, S2, S3, for example. Okay, so I get a list of virtual stores, all selected. I let the users select among a specific group of stores if necessary. Okay, and then it's gonna iterate over this virtual table. And thanks to the context transition, because here I invoke a measure, so it's gonna shift my row context into a filter context, because here I am iterating over this virtual table. I'm gonna compute the total sales on the fly. So it takes into account the filter context coming from other visuals. So let's say I have 100, then 200, and then 150. Okay, so this is the total sales, which is recomputed on the fly for each individual stores. Okay, then what this does is that it orders the DS virtual table by this measure descending. So basically, I get the following table then, which is sorted accordingly. So I get 200, 150, and 100, but actually these are the numbers. This is not what I get, because what I'm sorting are the stores. So I get S1, sorry, I get S2, S3, and S1. So this is what is returned in my virtual table. I get a list of the stores which are sorted in descending order by the total sales. And then what this does is that it picks the value chosen from the user. So in my case here, it was, let's say if it's 1, it's gonna take the first one, which is S2. If I choose 2 here, it's gonna take the second row. Actually, if you look at the documentation, index, it returns a table. And a good way to see it is that if, let's say here, I don't put store key, but just store, like this, you will see that I get an error. Why? Because I get all the columns of the store, which is the first one, or let's say here it was the second one, but let's put the first one. But then it returns a table with all the columns of the best store, which in this case is this one. But what I want here is to have a scalar value. I don't want to have all the different columns of this store. So this is why here I have put a column, so that actually it returns a table which contains exactly 1 row and 1 column. So basically, this table of 1 row and 1 column can be, or can shift into a scalar value, which I display on my screen. Okay, so very nice. And basically, this is what it does. So it's much more straightforward than before. You don't need to iterate first on the stores and then filter the corresponding one and get the name. The function.
So out of curiosity, for some of the technical stuff, because I love to like know what's under the hood is. Like, so there's always 2 things with any syntax sugar, right? The first is going to be like, is it easy for users to write? And that already solves a lot of problems, because it gives a broader audience of people who can utilize the function. The second thing that I'm always curious about is to like, is that the same pattern essentially as the DAX Studio one, but just with wrapping on top of it? So like, have you looked at the query plan at all of like, I guess how it's calling?
You just spoiled the next 5 minutes of my session, Reid.
So you've heard this statement before. I think it's Buck Woody, who's an MVP. A good question is one I can answer. A great question is answered on an upcoming slide. Yeah, because
so basically
to answer go ahead.
To answer your question, here it's not just about syntax sugar. It makes it easy. It makes it easier to code this kind of pattern, but it's also faster, So basically, we can investigate now. So what I'm going to do here, I'm going to go to DAX Studio from my local instance. And I'm going to compare. So now we have two measures which behave more or less the same way, or we think they behave the same way, and at least they return the same result. Now I'm going to run a query in order to compare their performance. And this is going to answer your question. So summarize columns. I'm going to put a little bit more grain in my analysis so that I have more rows and I have more query duration, because it's quite difficult to compare two measures when it only returns milliseconds. Like you need at least a few seconds in order to compare and draw some conclusions. So I'm going to put the date and let's say, for example, the brand. So I have a bit more grain. Now I'm going to put my top store. Okay. And now I'm going to drag the first one, which is the pattern from SQL BI before the existence of window functions. So what I'm going to do here, thanks to DAX Studio, I'm going to do two things. Here, I don't necessarily need the table. I'm going to focus on the log timer. And also, because I want to be able to compare each query independently, I'm going to clear the cache after, like when I start each query, I clear the cache so that I'm always in cold cache and I can easily compare my queries. So log timer and clear on run. So let's start. So this is the first one, as you can see on the top right, at the bottom right of the screen. It takes, yeah, now I have it here. So 40K rows returned, 7 seconds. Let's do it a few more times. 7 seconds, yeah, okay. Now the second one. Yeah, the same 7.3. Let's do a third one. This will be the last. And now what I'm going to do is that I'm going to run the same query, the same grain, but this time using the second measure. Okay, so the first one, old pattern, we're going to say 7.1 second, more or less. Now I'm just going to switch this to my new measure. Read, how long do you think it's going to last?
I'm going to say a 20%, 25% difference.
Let's try. Yeah, 6 seconds. Let's try a bit more. 4.3. Wow. 3.1. I'm clearing the cache every time, huh? So it's supposed to be quite stable.
Yeah. Well, any things like that. It's just maybe sometimes the computer is working harder on other stuff.
Exactly. But as you can see, we are always below 5 seconds, like apart from the first one. So as you can see, the new pattern with the window DAX, with the index DAX function, it's anything between 3.5 and 5 seconds.
Can you just humor me and turn on the query plan and server times for like 30 seconds? I'm just curious what some of the breakdown looks like between the two.
Yeah. So actually, let me rerun this. So what we see here, before reading the query plan and server timing, is that sorry, I should have put. I'm gonna go there just after.
You'll get the timings too. Yeah. Go ahead.
Yeah. We see that it's not, to answer your question, it's not just syntax sugar, right? It also, drastically increases the performance. Okay, so what do you want to, as you can see, mostly formula engine.
Which is good.
Yeah.
Yeah, you want very little in the storage engine, though. I will say that the interesting thing that is curious is that it does load 700,000 rows, even though it's mostly formula. So it doesn't have to. So the thing that implies is it's like it is loading a lot of rows to pull in the data, but it's not having to generate those rows. They're natural rows being brought in via relationships. Yeah.
Yeah, and if reading the query plan is a bit more technical, and if you want, we can compare the server timings with the old pattern. It's this one.
Well, the nice breakdown is to see how much formula engine versus storage engine, where the times go between those is by like where I always like to direct people. Like, even if you don't know how to read T-SQL, like this gives you a little bit of like how, the fast Ferrari versus constructing the car, so to speak. And then there's a little bit more on this one. Like you see, it's not a lot more storage in, but there is a little bit more on that comparatively.
Yeah. Yeah.
That has a bit more construction. And I think there's one extra evaluation that needs to be done.
Yeah. And
so one more line.
Even without reading the server timings and query plan and so on, it's quite understandable, because before we had to do 2 iterations. Like there were 2, even 3 if you wanted to get the value, but it was just 1 row. But let's say there were 2 iterations, whereas now we reduced from 2 iterations to only 1. Like I iterate here, and then because the returned, the whole concept of window functions is that you can work with tables which are sorted on the fly. So basically, here I have reduced from 2 iterations to only 1, because my table is already sorted. So if I want to have the first row, I just need to put 1, and that's it. I don't need to iterate again. So
exactly.
Yeah,
that's what I was wondering on this, is the like I'm assuming these were I think what it helps to imply is that the window functions were not only just syntax sugar, they probably like updated core functionality in the engine itself to likely be able to call upon better query patterns to more efficiently retrieve these things for people.
Yes. So before I go into the second example, I have a few more details and tricks to show you on this one. So for example, you can also use this function in order to return not necessarily the best, but the worst performers. Let's say I want to know who is the worst performer store. So if I go here, instead of ascending, I'm gonna put descending. I'm gonna put ascending. So this time, it's gonna sort my virtual table in ascending order, always on the same KPI, the total sales. And now you see something a bit weird here. You see that it returns 600, so as the store key. But when I sort my store key and total sales table, you see that the worst store seems to be this one, and I don't even see the store number 600. So do you have any ideas where it can come from, this? Yeah.
In terms of where in the query plan, or how the logic is evaluating it?
No, it's more about the content of the tables and the data. This is a bit tricky, but actually here, the thing is, I am iterating over all the stores in my referential. But if you have a look, you will see that I have some stores which do not have any sales.
Okay.
Right?
Okay. Yeah.
So the thing is, the engine doesn't know, like by default, if I use the default parameters in terms of sort order and stuff, it considers the blanks as part of the sorted table. Okay, I don't have this issue when I run descending orders sort, because I always have values which are higher than blank, right? But in this case, the thing is I have blank values and it impacts my worst performers. So in order to manage that, actually, if you go here, you see that this order by function allows you to treat the blanks in a very specific way. By default, it puts them first. Okay, so if I use the blanks first, you will see that it actually it's the default value. But if I go here and then I put blanks last, you will see that now the blanks are considered as the best, which in this case, it's perfect because I don't want them to influence my sort order in ascending. And now you see that my worst performer is indeed this one. And my
okay.
third
Yep.
worst performer is actually this one. Yep. So it's
Yeah,
quite
okay,
nice.
okay.
Okay. The last thing I wanted to show you, let's go back to the descending order, is that sometimes you can have ties when you rank data. You can have values which are exactly equal. So let me go back to my explanation here. Okay, going back to this. So all selected, I'm going to have store 1, store 2, store 3. Okay, and let's assume that I have like this. I have two stores which do have exactly the same sales. It can happen sometimes. So what this will do, it will create a virtual table like this. S1, it will respect the order of the table, and then S2, which is of course lower. But then the problem is these two stores have exactly the same sales in the given filter context. They have 150 each. And the thing is, index, in this case, if you, so for example, here, if I put 1, so if I want the number 1, index will pick S1 because this is the order of the data. It will not care if there are duplicates or ties or whatever. So the trick here, if you have this kind of situation, is that you can actually, in the order by clause, you can mention multiple ways to sort the data. So for example, in this case, I could say, okay, if I have ties on the sales, then I will sort my table maybe on the number of orders, which is a second criteria. And in this case, it will help maybe or not adjust the sort order of my table and choose the correct store. Okay, but I found it was an interesting way to treat the ties. It's to play with the different arguments of order by.
Yeah, well, I mean,
So
the
this
fact that you can turn a lot of these dynamic is really nice.
Yeah, and actually, because these are measures, you can actually here make them dynamic, make a switch, or make a calculation group. It's totally dynamic and model driven. Yeah. Okay, so that was the first demo about index. You saw how to implement this logic in order to retrieve the given rank of a store. Of course, I could use it on other objects such as products, customers, and whatever. You saw that the syntax of the index function makes it easier, but also faster to compute. We saw it in the example in DAX Studio. And then I showed you some tips and tricks in order to manage the blanks and the ties, which are quite common when it comes to ranking patterns. Okay, are there any questions on the... No, I see that someone is saying partition by is nice. Yes, it's coming in the last demo. I will use partition by as well. Yes.
Good.
So, okay, now let's do a more advanced example. I'm sure, Reid, you have already heard and probably implemented in DAX the Pareto chart, where you want to create a running sum of a given object. It could be products, customers, stores, whatever, countries, and then you want to have the cumulative version of this so that you can add up all the different values and have this running sum all over the chart. Yeah, you have already built this before?
Yeah, years ago, it was like actually Parker Stevens when he was Power BI Park doing stuff. He did a guest post like 6 years ago where we used DAX to build a Pareto chart.
And actually, before DAX window functions, it wasn't that easy to do that. Again, it required quite a good level of DAX, understanding the concepts of virtual tables, context transition, and it was a bit slow to compute as well, especially if there was a big number of items or stores or whatever to be iterated and then displayed on the Pareto chart. Okay, so I'm going to show you how you can leverage the window function. There is a window function called window, which you can use in order to manage this kind of pattern. So this is my second demo. I'm going to use the window function in order to build a Pareto chart. So here what I'm going to do, I'm going to call it test. So basically, the window function, what it does is that it's going to create basically a window. So you can imagine a window like a virtual table, and it's going to allow you to adjust the depth, let's say, of the window based on the different parameters that you put here, especially the four parameters here from type to type. And then, as you can see, the other parameters are a bit the same as the first window function that we use, which is index, where you're going to say, okay, on which table, how do you want to sort, and so on. But here, the very specific and complexity of window are these parameters. So I'm going to code it because it's not very easy to explain. So first, I'm going to code the logic, and then I will explain to you the different parameters and syntax. So what I'm going to do here, window, I'm going to say from 0, from type absolute to 0 relative, sorry. I'm going to apply this on my store key, which is the column in my chart that I want to have the Pareto chart on. Order by. Here now it's the same as the window function. Yeah, order by. I will put total sales descending order. And basically, that's it. So the problem is, if I do this and if I put the window on my chart, I will have an error. Why? Because exactly like index function, window, the function window, returns a table in this case. So as you know, measures cannot return a table. They have to return a scalar value, whether it's text, number, or a date. Here in this case, I am using a function which returns a table. And unfortunately, unlike the first example, this table does not have one row and one column that can be easily shifted into a scalar value. It's a bit more complex than that. So, for example, if I want to understand a bit more what's going under the hood, I'm going to put this under count rows so that I can shift from a virtual table to a scalar value. So as you can see here, my window function is cumulative. Here I have one value. As you can see, my chart it's stored in descending order. So I have one row in my virtual table, 2 rows, 3 rows, 4 rows, and so on. So it seems to work. It seems to create this kind of window that I need. Here I want to sum the first row and then the top 2 rows and then the top 3 rows and so on. So here we have, in this example, the whole complexity of DAX. How to visualize what's going on under the hood. Like this virtual table, I want to know its content. I want to know how it's the behavior and what are the actual values in my window. So to do that, there is a pattern in DAX where you can actually visualize the content of your virtual table. Here I'm just counting, which is nice, but it's not enough if I really want to understand the logic. And actually, as a teacher, it's going to help me also as well explain to you the logic of window. So what I'm going to do is that I'm going to create a concatenatics on this table. Okay. Actually, let me put this in a variable. So I'm going to say let's say window stores, and then I'm going to put this so that it's a bit easier to read. Okay, and I'm going to say return. So, sorry, I forgot concatenatics. So my table, it will be window stores, expression, store key, delimiter, this. So now it's very nice because thanks to this pattern, concatenatics, it's a DAX function which is scanning all the rows of my window stores virtual table, and it helps me see the values inside this virtual table. So let me do it a bit like this. So
nice.
As you can see here, now I can clearly see that window, in this case, I have one row and I see the store number of this one row. And then I have 2 stores and 3 stores. And then you see the content of this window live, like it adjusts on the fly and it recomputes the content based on the sort order of my total sales. So it's quite nice because thanks to this pattern, I can actually visualize how my virtual window function computes the virtual table. Now that you see this, we're gonna adjust a little bit these parameters for you to better understand how to use them. So for example, if I put here relative, so I have 2 options. Either it's absolute or relative. I'm gonna put relative here. So if I do that, you will see that actually my window keeps moving. Relative means, let's say, the current row or the current filter context. So if I put 0 and 0, it actually creates only a window of 1 row every time. Absolute helps me fix that. If I put apps here, it's like in Excel, when when you lock a cell, it's actually the same. So apps actually helps me say, okay, no matter how the window will be in the future, I always want to start from the very beginning of the window, which is my virtual table iterated by stores and ordered by the total sales. So I'm gonna fix this in order to make sure that I always have this row and then the second row and so on and so on. And then the second part, actually it's the same. If I put absolute here, you will see that, let me validate. You will see that actually, no matter what is the current context, it fixes always the first row, the first store. This is not what I want. I want it to be incremental. I want it to add it every row. So in order to do that, I can just say relative. And in this case, it will just create the corresponding window. Nice. Trust me, Reed, this is very hard to explain, especially in English for me because I'm French.
Yeah.
Was it clear or yeah?
I think, well, having the visual as well to show the concatenation, I think is a great visual representation. So that was, for me, and I'm sure some others, very helpful.
Nice. But we are not done because this is not what we want, right? Now we want the corresponding cells of this virtual table, right? So how to do that? Instead of concatenatics, we're going to say, okay, calculate the total sales for this window. Yes?
Yep.
So now it works. So I have my, so now it's not test. We're going to say Pareto stores total sales. So this is a measure, okay, which recomputes on the fly the total of my stores. And of course, it's dynamic. So if I filter on a specific country or on a specific set of date, it always recomputes on the fly, right? So that's very nice. Okay. So now you might say, okay, Tristan, but this is very complex. Okay, you introduced the window function through this practical example, but I'm not sure to fully understand how to make it work and so on. So the good news is I have 2 options in order to make it easier and simpler for you. The first option is that I can put this logic into a DAX UDF, into a DAX user-defined function, in order to make it easier for any future use. The second tip here is maybe to use actually visual calculation. So I'm going to do both, and Reid, you will tell me which one you prefer. And again, we will also compare the performance. So actually, let me copy this. And what I'm going to do is that I am going to put this logic and make it generic. I'm going to transform it into a function, a user-defined function. So to do that, I'm going to go here. I'm going to create a new function. So it's going to be define function. I'm going to call it. So here I can put a description, Pareto pattern, for example. So this will be Pareto equals, then I'm going to pass my parameters. I'm going to copy my code, and we're going to have a look at what can we make dynamic here. So what I can make dynamic here, it's this part, right? I want to make it generic, the store on which I am iterating, like the object, the dimension, and also the measure on which I want to apply this Pareto logic. So how to do that? I'm going to create a first parameter, which will be called call Pareto any ref. So it allows me to call a virtual table. And then the second parameter will be measure Pareto, and it will be an expression. And I'm going to pass this in order to make it generic. So here, all selected, it will be my call Pareto. And this one and this one, it will be measure Pareto. Okay, so basically, I turned a DAX measure into a function by transforming some parameters and making them generic. So I'm going to update this. Update. If you haven't understood anything at all on this one, it's totally okay, because this is exactly the role of this function. It's to make things easier for you. So now, instead of coding this quite complex pattern, I can just call my UDF and say, create a new measure, Pareto stores equals Pareto. So this is my DAX UDF. I'm just going to call my store key and my total sales. And that's it. Very easy. Let me format this. Put it in the chart. And it works. Beautiful. So now, if you haven't understood anything at all about the window functions and stuff, it's okay. Someone in the organization or someone in the community created this for you. So in order to make the pattern easier and to hide the complexity to you, basically. Okay?
Oh yeah, and hence the reason why you and a lot of other people in the community really like UDFs, is they're great for producing needed patterns for the people who do need them.
Exactly. So what do you think about this method, Reid, like creating the window function, putting it in a DAX UDF? What do you think?
I think it's already simplified the Pareto pattern, having that. It was more complicated to do previously, to be able to get those ranges and everything. And then I think it's just further icing on the cake to be able to pair some of these now with UDFs. If anything, I think it actually might probably further increase the usage of a lot of these window functions, not by the end user, but by people making patterns for UDFs to leverage them.
Yes, and I've tried. There is no, you have to be careful, of course, because UDF are still in preview, but in terms of performance and capacity units consumption, it's actually it's exactly the same. So this measure and this measure, which uses the DAX UDF, returns, of course, the same results, but also have more or less They have the same performance and the same capacity unit consumption. Okay. So now there is actually another option now, again, thanks to window functions, in order to have this Pareto cumulative values. I talked about it a little bit earlier. I don't know if you paid attention. Read, there is another method in order to make it even easier to compute this on the fly.
Okay.
Do you have any ideas on how?
You were saying you alluded to it earlier, but no, I must have missed that part.
So I am actually referring to visual calculations, which are very nice in this case because they only compute at the visual level and they know the sort order and so on. So let's try that. Actually, I'm going to go to where is it again? I always, is it modeling, new visual calculation, sorry. So actually, this is a new feature in Power BI which allows you to compute DAX logic into a specific visual. And as you can see, there is already a pattern for running sum. Let's try it. So I want to run the sum on my total sales. And you're like, oh, this is easy. But no, it's not working. And the reason why it's not working, it's because this logic, the running sum from the visual calc, will just take into account natively, it will take into account the order of the store key, which is text in my case. But that's not what I want, right? I want a running sum based on the sort order of the total sales, right? This is the problem. So let me first format my specific column here. Okay. So in order to have the correct result and to have a running sum which takes into account the sort order based on the total sales, again, window function to the rescue. Here I can pass a second parameter, which is order by. And that's it. Sorry.
Oh, okay.
I should have put descending because by default it's ascending.
And the thing too is it can speed up the calculations as well, because anything that's calculated after the visual loads will increase efficiency.
Wait, because that's exactly, yeah. So you might say, okay, we are running this at the visual level. It's working, as you can see. So it recomputes on the fly. I have the same result as my DAX UDF here. It's perfect. But now it's even easier because I didn't have to care about anything. It was just quite easy to calculate and stuff. Okay, now the thing is, let's compare the performance on the visual calc and my Pareto sales measure. So you're saying that it's faster to use the visual calc, huh, Reed? Huh? This is what you're saying, huh?
I mean, the less the query engine has to do against the model, it should be faster.
Okay, let's try. So let's investigate. I'm going to go to optimize and I'm going to run the performance analyzer. So this first query, I will benchmark the running sum. But actually, in order to do that, let me do it on a more granular. Let's do it on the product. Okay, so that I have more data because I only have 70 stores, but here I have 200, maybe 500 products. Okay, so let me clear, refresh. So my running sum is working, as you can see, it's perfect and it recomputes on the fly and stuff. Okay, so now I'm gonna put this, copy. I'm gonna go back to our favorite tool, DAX Studio. I'm gonna close this, refresh the metadata, clear the cache, log timer, and I'm gonna copy the query coming from the visual calc. So you see it's around 5.4 seconds. Let's do it a few more times. 5.4. Wow, 7.1.
Okay.
So it's using this time the Visual Calc 5.4. Okay. So let's say anything around the Viz Calc, more or less 6 seconds, let's say. Okay. Now I'm going to use the same, but this time I'm going to create a new measure, and I'm going to use, this is the beauty of the DAX UDF. I can reuse my DAX UDF to compute my Pareto on the product key. So total sales, Pareto product, because the last one was on the stores. So I'm just going to say Pareto, product key, yep, and total sales. Yep. And let's check, but it's supposed to work. Let's check. It's here. Yes, it works. I have my running sum and it recomputes on the fly quite quickly. So now let's take the corresponding DAX query. I'm going to copy it, paste it. So in your opinion, it should be slower, right? Because now I'm not using the Visual Calc anymore. I'm using the measure which computes everything on the fly using the model.
In theory, yeah. I feel like you're saying in a tone where it's probably not going to be.
It's actually faster. As you can see here, well, yeah, 7. Let's do it again. When I didn't have StreamYard, the difference was a bit higher. Like it was really faster. Yeah, 4.4.
I mean, the first one was 2 seconds, then it went to 7, then it went to 4. So, and then yeah, I mean, so it is seems to be on average like 30% faster.
Yeah. So the thing is, and I was a bit surprised too. I would expect Visual Calcs to perform faster than anything driven by the model here, because
I would agree.
Yeah, but the thing is, probably there are some things happening in the engine. Maybe we should ask Jay about this specific use case of why visual calcs don't perform faster than the actual measure, which has to do all that kind of stuff. But actually, it's very interesting. But to be honest, the visual calc has one big advantage compared to the measure, is that it adapts on the fly on the object I am using here. So for example, oh, did I remove it? I removed my, oh yeah, I should have kept it. Yeah, it's okay. Let's rebuild it very quickly. It's gonna take 2 seconds. Insert. Why I don't have? Yeah, this is sometimes I don't know why you see the new. Okay, let's do it again. Product key.
No worries.
Sometimes the visual. It just new visual calc. Okay, running sum. Let's do it again.
Yeah, I've seen those where it's it's tricky to get to the menu.
Running sum total sales. Order by. Yes, it's back. The last thing that I wanted to show about the visual calc and that I really like is that it adapts to the context without having to force or change on which column or table I'm supposed to iterate. So for example, if I put my Pareto on product here, you will see that my measure forces on which object do I have to do my Pareto? So here it's product. It's working. But as soon as I change the filter context, so for example, if I put here, let's say the brand, the visual calc will work because it understands that it needs to adapt to the context, whereas the measure, because the measure forces the grain of the product key, doesn't work, as you can see here. It only works at the product key level. And I would need to make much more complex DAX in order to manage depending on the grain. And this would be doable, but this would be much more complicated than just using a visual calc in this case. So to conclude on this pattern, visual calcs makes it easier to code, and also they adapt to the context. Surprisingly, they are a bit slower than native, let's say, DAX measures and stuff in order to compute the Pareto. So depending on your need, depending on the things that you want to do, you may use one or the other. I don't know what you think about this, Reed, but yeah, that was interesting, I think, to compare.
Well, the thing that is there is a cost apparently to visual calcs, but the payoff is that it gets more context on the shape of the visual with specific functions that that is explicit to it. So the benefit is, to your point, is that it's much more flexible and adaptable without having to write super complex code to account for a bunch of different columns and fields and everything else. So it seems like a better place to write it in, if anything, is in here versus directly in a regular measure.
Exactly. So that was my second example. Do I still have maybe 5 minutes for the last example, which is much faster to explain? Yeah?
Sure, absolutely.
Okay, so I have shown you how to use window functions in measures, in visual calculations, and so on. You can actually also use window functions on calculated columns. And I know that some people in the community say that we should never use calculated columns. I don't necessarily agree with this. There are some business use cases where you need to add columns to your model, and you don't always have the chance to have a Fabric or Snowflake or BigQuery or whatever data warehouse. Sometimes you're just on your own with Power Query and DAX, and you need to figure out how to give the report to the manager and how to create this specific column or KPI. So you need to find some solutions. And I faced many times this use case where I didn't have the chance to have a data warehouse. So I was only just purely Power Query or DAX. And sometimes you receive this kind of very annoying table, for example, in Excel or from APIs or whatever, where actually the sales are in year to date, which is really awful in terms of BI and modeling, because you don't want to display individual values and you cannot sum up this column. Have you ever encountered this kind of use case before, Reed?
Not directly. I think I've seen some posts that have had similar issues as this or a need for it, but yeah, never directly myself.
Yeah, so trust me, sometimes there are some sources, APIs and stuff where you receive this kind of annoying sales or quantities or whatever, which are in year to date. You can actually use a window function, which is called offset, in order to retrieve the previous row, basically. The concept of previous row is quite hard to grasp in DAX. It's not easy to implement, but thanks to offset, you can do it. So that would be my last demo. I'm going to create a new column. And this new column will try to compute not the year-to-date sales, but the monthly sales. So for example, for France, here it will be 35, and then the difference in subtraction and so on. Okay, so monthly sales. This is a calculated column this time, not a measure. First, if sorry, there is a dog. Okay.
No worries.
Month equals 1. So if I'm starting the year, basically, I don't need to get the previous row, right? I can just take as a starter my first. So here, 1st January, the same here. Okay, I don't need to retrieve the previous row because this is the first month of the year. I only need to retrieve the previous row when I'm starting on the month number 2, month number 3, and so on. And in order to do that, we're going to use a DAX window function. This time it's offset. It allows me to move within a specific table, offset. You see, again, it's a bit the same syntax as before. The only difference here is the delta. Index, it picks a specific row, let's say, or index in the virtual table, whereas this time it shifts either backwards or onward in the virtual table. So here I'm going to say -1 because I want to have the previous row. The table on which I want to iterate, it's actually this one. I will explain this a bit later. So country, dates, and year-to-date sales. Okay, so this is the table. Order by. So this time my order will be the date in ascending order because I want to make sure that the dates are sorted appropriately. And this time, yes, I will use partition by. Why? Because I want to make sure that I have this logic implemented, but for each country, of course, because I have 2 countries here in my table. So I want to make sure that when I retrieve the previous row, I do it for the specific country I am analyzing in my row context. So to do that, partition by country. It's a bit complex, but trust me, it's very fast and it's easier than before. Because before, in order to retrieve the previous row, it was a bit the same. You had to do multiple iterations and it was not that easy. Here, the syntax is a little bit complex, but it's super powerful. So the thing is, if I do this, I will have the same issue. Why? Because again, like window, like index, offset returns a table. Actually, it returns a table of, actually, for example, in this case here, it returns this table. It returns the previous row, but of all the columns. So if I want to have this specific value, which is this one, I'm going to say select columns of this virtual table. Year-to-date previous sales, let's say. And this will be year-to-date sales. And if I do this, now you see that first row, I have my individual value. Second row, I have the previous row. Third row, previous row, here, here. So it's working perfectly. Now, in order to get my monthly sales, I can just say year-to-date minus this. And there we go. Thanks to my window function, I can shift from year-to-date, or let's say quarter-to-date or whatever, to monthly data. And it's quite nice. And again, if you find this a little bit complex, I reckon it's a bit complex, you can completely embed this into a DAX UDF for once and just reuse it in all your models and all your, and even I was, maybe considering putting this in the DAX lib so that really everyone in the community can benefit from this, because you can do the same and put this into a DAX UDF if you want to hide the complexity of this.
Yeah, the fact that I think you can reverse engineer is a rather nice pattern to be able to bring in if you're dealing with CSV exports or any other SaaS products that gives you like report data rather than actual raw data.
Yeah. So I'm done with the demos. I have shown you 3 examples: one with index, one with a window, and one with offset. These were quite advanced scenarios. I reckon you don't necessarily face this every day. But I think these are interesting use cases which show the power and the flexibility that the window functions can offer. And we saw that most of the times they simplify the syntax and they make it also faster when we compared with the, with the first demo with the double iterations and the second demo when we compared to the visual calc. We saw that the window function was not only easier but faster to compute. So very, very interested. I really suggest you to have a look at these functions and investigate a bit more, because they definitely open many windows or many doors for advanced analysis. Yeah.
Can you switch back to here as well? No, I think you've given good use cases, but if anything, actually, this is probably just a further example of some of the benefits of visual calcs and UDFs is like a secondary thing with those as well. I think they're nice on their own, but yeah, I think a lot of these will probably be better served in upstream patterns that can for some of them at least. Like the index one's pretty easy to use by itself, but I think with the offset and some of the other windows, like those will, yeah, repeatable UDF patterns, it seems like there will be bigger benefit for them. It sounds like from watching you and listening to you.
Completely agree with you. And by the way, on Twitter a few weeks ago, I shared a screenshot of the UDF equivalent of the last pattern with the previous row. And I don't know, I got like 150 likes, 20K views. Like people really wait for this kind of pattern to simplify and hide the complexity. Yeah.
Yeah, I mean, it's it's surprising sometimes what's popular with people with with certain functions. But I think at the end of the day is if you can solve a problem or simplify a problem, like that's where a lot of the DAX wins comes in, because it's already a full-fledged language. It's really at this point it's just the only updates to it at this point are making it faster or making it easier to write.
Exactly, and as we saw in this session, sometimes not all the time, but sometimes window functions offer both simplicity and fast performance. But yeah.
As we wrap up, I always like to ask, are there any final takeaways or specific references, links, or resources you recommend people check out to explore any of the things you've covered today?
Yeah, so my first suggestion, of course, as always, is to explore SQL BI blog and videos, especially on window functions. They published quite a few articles. SQL BI, most of the time, they focus on the internals. That's why when I make this kind of session, I like to make concrete business use cases, because I think it's quite complementary with what SQL BI or other experts are sharing. So if you're looking at a more deep dive, understanding the under the hood of the window functions and stuff, I definitely suggest to have a look at SQL BI. Maybe also have a look at this video again in a few days in order to digest. And my last recommendation also is have a look at SQL, because in SQL, these window functions have been here forever. And partition, row, and stuff. And trust me, even myself, by learning SQL, I got better at DAX, because there are some concepts. Some concepts are very different, but some concepts are very similar. And when we talk about window functions and stuff, I suspect Microsoft took some code and some logic from SQL in order to implement it into the DAX window functions. So by exploring SQL and especially SQL window functions, you will also probably be better at DAX and DAX window patterns too.
Yeah, I mean, a lot of I think goes into the learnings is the more you can understand about this, the way the filter context works with a lot of this, I think it gives a secondary benefit of really helping understand the language a little bit better. One of the things that I actually liked about that you were showing with some of these things with the SQL BI patterns is in general, you with any of these things, whether that's what you've shown or any others, I think it's important for anybody dealing with DAX. If you already use a pattern, it might give you the right number, but take a little bit of extra time to ensure you roughly understand how it works, because if it ever stops working, you are now the responsible party to fix it or to explain it. So don't just blindly use patterns. Take a few extra minutes to understand it a bit, just in case something goes wrong, or if the number changes, you can reverse engineer. Is it in the measure? Is it in the table? Is it upstream? Because you at some point you have to find the problem, and the first place to look is always going to be the DAX measure, because that's the end of the journey, essentially, in the visual.
Yeah.
So, yeah.
FabCon in Atlanta, so I just submitted 2 sessions. Hopefully, I can make it this year. Yeah.
Yeah, for people curious, Steve and I, my business partner, we got accepted for a workshop that will be announced, once it goes public. So we'll do a workshop there, and I'm thinking we'll have some of our sessions accepted, because I think you can only get like almost an automatic session, but we will be there in Atlanta to do some of that stuff. And then fingers crossed for SQL Bits, I'll be applying to that, and Power BI Deep Dive is coming back, the cruise. I'm excited for that.
Nice.
I don't know if you're applying for that, but being able to present on a cruise ship seems fun. So I'll apply it for.
Yeah, do it on a cruise, and the other objective I had is to do a conference on Power BI conference on every continent. So I still have some continents to explore and to tick. Yeah.
Exactly. Cool.
Thank you very much.
Absolutely. Then, I'll looking forward to getting you back on again, and enjoy the rest of your night. And everyone, thanks for tuning in. See you on the next live stream.
See you. Bye.
All right. Cheers.